We've got some great talks here today, ranging from monitoring the ocean floor to large language models at M&S, which is where we're going to get started today with John Mildenhall. Please put your hands together, please.
All right. Thank you. Hello, everyone. Thanks for coming to my talk. My name is John Mildenhall. I am head of data science at Marks & Spencer for retail. Part of a large data science team. We've got about 50 people in that team, and we're building systems that make the company better, a better place to work and better for customers, of which I'm sure there are some in the audience who count themselves as customers of M&S. My relationship with AI and large language models goes back quite a long way. I actually started out as a neuropsychologist, was dealing with natural language processing way back in the early 2000s, and I think this year's my 20th anniversary of building my first neural network. So it's been a long journey, but it's getting really, really exciting recently. So we talked we had a talk in the earlier session about back in 2022 when everyone started getting excited about this, and we were definitely aware of what was going on in the world of generative AI, and we started playing with things, and this is kind of like from that sort of era. And the typical experience you get, we're like, well, you can make some pretty exciting things. This was the prompt we put in. But then you start thinking, well, hang on a second, where are their heads and where are their hands? This has obviously been prompt engineered to not show hands, not show heads, because at that stage, DALL-E 2 just couldn't do it, and it was terrifying if you actually tried to make it do it. So we started getting very excited about the world of large language models and also generative image models as well. And we immediately realized that there's going to be a lot of work needed to be done to stop bad things happen, right? So like this is my entry into the kind of LLMs do funny things competition. This one's from Amazon, but like look at the name of that product. If you type in as a large language model into almost any marketplace you care, like Amazon, Etsy, whatever, you will get thousands of hits. It's already deeply, deeply affecting our information landscape. In this case, negatively. This is a kind of example of poor data quality and a poor outcome. We need to avoid that, and certainly with M&S, a FTSE 100 company, it's got one of the biggest brand recognitions in the country. It's also a global company. We're in 40 countries at the moment. So we started talking about capabilities. What can these large language models and generative imagery models actually do for us? And you start thinking, well, obviously there's chatbots, right? Free text to free text. But the more you think about it, the more sort of interesting things start coming out of the woodwork. Like, well, actually, can you generate SQL, so query language from large language models? Turns out you can. So you can say, okay, I want a query to find out what's the aggregate of this particular product category sales last week from this store, and it will give you, more often than not, the SQL that is correct, that actually pulls that database and gives you back an answer. And so you can start to build some pretty interesting applications that you would never really guess are a generative AI under the hood, but they actually are. And these get more and more ambitious, all the way up to probably the most ambitious, which is like what I call agentic, so an agent. You could imagine creating an application that would be just sitting in your data, like finding out interesting things all the time. We generate a huge amount of information. Little factoid about M&S, we sell 20 Percy pigs every second. Each one of those is a new row of data. So like if you could actually visualize the data kind of getting bigger, it would be like probably going 10 miles an hour. Like at any given time, if you were printing it out. So, being able to turn these, what started out as quite cool demos, interesting technologies, into something that's really, really useful is kind of like been a tantalizing prospect for a little bit of time now. And then moving from capabilities, we get onto use cases. And this is, I can't show you the latest one because we're a commercial organization, but this is the scenario about a year ago. We had about 57 use cases for generative AI. The kind of really obvious ones, chatbots in store. Could you ask a chatbot, I'm looking for a cerise pullover, do we have one? Yes, I think is the answer to that. Making it actually happen 100% of the time reliably, not doing anything bad, that's the key, and that's what we're trying to get to. And that journey is going to be long and involved. And for that reason, when we talk about chatbots, we try and talk about that building that capability rather than building an individual chatbot. And so I say 500 chatbots, not 5. What would it take to build 500? And the reason for that is because a priori, when you set out on your chatbot journey, you don't know how well it's going to go, right? So here's my spectrum of outcomes for chatbots that I invented last week. And it's ranges from dangerous to valuable, all the way through useless and passable. And so you say, okay, well, we've got this product expert bot, this bot that's going to tell us about, say, a pullover. Where can that go on the spectrum? Well, if it's about clothing, probably wouldn't ever be dangerous. Food very much can be dangerous. There are about 4 or 5 different ways you can go to prison for running a store incorrectly in this country. One of them selling date-expired food. There's another one which is called Natasha's Law, and that was a very sad story about someone who very sadly died as a result of an anaphylactic shock to some allergens that were present in the factory but were not mentioned on the label of the food because they weren't actually supposed to be in that food, but they were in that case. So we have to be able to not only meet kind of ethical, moral guidelines, but also legal ones as well. And when you start out, you don't know where you're going to land. So you might land on dangerous, and then the question becomes, well, how much effort is it if we iterate on this chatbot to go further and further and further to the right? Like, what will it take to get to useless from dangerous? It's an improvement, it's not good enough. What will it get to passable? So you need to make many, many, many bets on individual large language model applications in order to get to ones that are actually going to be useful in the end, and then potentially valuable, profitable, which is what we're after as a business organization. So what have we done? We built a conversational AI factory. The purpose of this is to make that process of building large language model-based applications really, really quick and really, really efficient. We can now spin up a generative chatbot endpoint within about 15 to 20 minutes using kind of our cloud resources, which we have like extensive capacity for. And that builds a service which allows you to poll it for an answer, and it becomes an expert on a set of documents. We're kind of an internal consultancy. We have clients who bring us their use cases. And what do they need to bring? They need to bring knowledge-based documents. They need to bring question and answer examples. We need to do some prompt engineering on top of those as well, and then guardrails and legal guidelines on top of that. And that gets you to the point of your first potentially dangerous chatbot. And after that, it's about improving it. So what we've done here is build a system that builds the chatbot, but it also tries to build guardrails, and it tries to build things that stop it doing undesirable responses, which we call MegaJudge. So that's another large language model which is checking the homework of the first one. And then we're also potentially building another legal one, which is literally just devoted to saying, is this answer illegal in some way, yes or no answer? And that's the kind of the point that we're at right now. We can do this. We need to get it into production in the real world with real colleagues using it. And that's the journey that we're on right now. So this is the first example. It's a chatbot for store operating procedures. That's in food. So we ask it a question: which bakery products are excluded from being donated? We donate a lot of food to charity when it is about to become date expired. And there are a few that, sorry, I don't know why that's gone over there. There are a few that are excluded from that, and it gives you that answer. And that's contained in a PDF. It gives you a link to the PDF and gives you the page number, so you can go and check that for yourself. To get this actually out into production in the wild, being used by 55,000 colleagues potentially, you're going to need some AI governance. What that looks like is something we're still working through, because there's a lot of touch points you have to consider. So this is an example of what it could look like, because we need to talk to different business units. We have food, we have clothing and home, we have banking potentially. We have a digital and tech organization. We have finance, that's very important. They need to have a oversight into it. The board has a responsibility. If you look at the embarrassing things that LLMs have done for commercial organizations, the list just keeps getting longer, right? You'll have seen people like getting a chatbot to agree to sell them a car for $1, that sort of thing that we need to have board oversight to be able to prevent, and then a risk committee, which we already have, but it needs to now be attuned to the world of AI and not just the kind of traditional risks it's been dealing with up to this point. So we are building that as we speak. And then just wanted to leave you on a kind of, hopefully a little bit of a pose and a little bit of a promising thing that we've been looking at recently. And I've already talked about, you have a chatbot, you send your prompt, you send your content through a prompt engineering process, you do some inference, you get a response, and it comes back to the user. We're then building components that do guardrails and check that it's not doing anything illegal. What if you could improve the speed at which you improve your chatbot by building another loop, an outer loop, which is kind of like a meta learner? What does that mean? Well, we have an example where we try and write copy for our website. So how do you describe this jumper? That's a classic use case for large language models. What you end up doing in reality when you try and develop an AI application for that is you spend loads and loads of time talking about the intricacies of each individual response you get from that chatbot. So, for example, no, you cannot use the words on fleek to describe an M&S product. It's not acceptable. That's off-brand language. So we just have this enormous spreadsheet of things that it can and can't do. If we could get a large language model to derive those rules, that would make it much quicker, and that's what we're trying to look at right now. And that's it. If you'd like to find out more about doing a career in commercial data science, I have a book which you might want to check out. And that's it. Thank you.